Good morning, class. Today we will perform the second type of chemical reactions, which are substitution reactions. We explained before there are two types of substitution reactions, which are simple substitutions and double substitution reactions. Let's start to perform the first type of reactions, which are simple substitution reactions. The first reaction, the reaction between metal and water. Reaction between metal and water. We explain that when sodium reacts with water, what the product, the results? Sodium substitute hydrogen of water. Sodium will substitute hydrogen of why? Why sodium substitute hydrogen of water?
Because the activity of sodium is more than the activity of hydrogen.
Good, because the sodium above hydrogen in chemical activity series. So sodium is more active than hydrogen. Sodium is more active than hydrogen. So sodium will substitute hydrogen from water, forming sodium hydroxide, metal hydroxide, and what the evolving gas? Hydrogen gas. Hydrogen gas evolved. Hydrogen gas evolved. This reaction accompanied by heat. Right? When we touch the beaker, we find that the pressure of the beaker increase. This is a reaction accompanied by explosion. Let's perform the first reaction. It's a dangerous thing. Be careful. Put water. Beaker. And then a small piece of sodium metal. Just a small piece. Sodium metal is very active metal. So we preserve under kerosene, on the surface of kerosene. This oil is kerosene because it's very active, it can react with air. So we preserve sodium. Yes, in kerosene. We take very small piece of sodium. Okay, when sodium, water, with the reaction. Be careful. Sodium reacts with water and hydrogen gas evolved. Sodium metal is very active metal. During the reaction, sodium substitutes hydrogen from water. This evolving gas is hydrogen gas. When you touch the beaker, you find the temperature of the beaker increase because this reaction is accompanied by evolving heat. Increasing of heat. Sodium hydroxide. This solution is this solution. Sodium hydroxide. Okay. So sodium reacts with water. Sodium substitute hydrogen of water and metal hydroxide. Sodium hydroxide is formed. This is the first simple substitution reaction. Simple substitution reaction. After that, we explain the substitution of metal to hydrogen of acid. Metal substitute hydrogen of acid. We have three types of metal, which are number one, zinc, aluminium, and copper. Zinc, aluminium, and copper. Zinc, aluminium, and copper react with hydrochloric acid dilute. Yes, react with acid to substitute the hydrogen of acid. Hydrochloric acid must be diluted. We have hydrochloric, we have concentrated hydrochloric acid. So we must make dilution process. Dilution means add some water. Yes, add some water to acid. Add acid to water. Add acid to water. Acid to water. This process known as dilution process. Okay. Now we have diluted hydrochloric acid. Diluted hydrochloric acid. Now let's make the first reaction between metal and hydrochloric acid. The first metal is zinc. Take some zinc. Zinc metal. Here. No. Okay. Add hydrochloric acid. Add hydrochloric acid. Add hydrochloric acid. Yes. Add hydrochloric acid. About the Look. Bubbles is forming. Bubbles is forming. These bubbles mean zinc has react with hydrochloric acid and little amount of gas is evolving. These bubbles mean zinc is react with hydrochloric acid and little amount of hydrogen gas is evolving. Little amount of hydrogen gas is evolving. Okay? Thank you, mind. Shian, perform the second activity. The second activity with aluminium react with hydrochloric acid. Aluminium metal. Aluminium. Yes. Aluminium. Look. This is the structure of aluminium metal. Aluminium solid metal. Aluminium solid metal. Okay? Aluminium solid metal. We put some hydrochloric acid, pour some hydrochloric acid above the metal. Above the metal. When we put hydrochloric acid above the aluminium metal, thank you. The reaction doesn't occur immediately. The reaction doesn't occur. It will take short time to react, right? Why it will take short time to react? No? After short time, start to forming bubbles. It takes short time to forming bubbles. Why? Why aluminium takes short time? As it comes before zinc in chemical activity series. Why? Why?
More active. This is more active.
No, due to formation a layer of aluminium oxide above aluminium metal. Right? This time need to remove the layer of aluminium oxide and let the metal exposed to acid and let the metal exposed to acid. Come on. And let the metal exposed to acid. So aluminium takes short time. Aluminium ya Muhammad take short time. While zinc react immediately. So ya Ahmed, give reason. Also aluminium comes before zinc in the chemical activity series. Aluminium takes short time. Take more time than zinc to react. Due to formation a layer of aluminium oxide, which take more time to remove this layer and the metal exposed to acid and the metal exposed to acid. Where are we? We didn't finish the glove at all because when copper acts with hydrochloric acid. What's happened when copper acts with hydrochloric acid? No reaction. Why? Why there is no reaction between copper and this one?
Because copper is less active than hydrogen.
Because copper is less active than? Why?
Because it because
Absorb or follow hydrogen in the chemical activity series. Now see the reaction between copper metal. Copper. With copper. Yes. Copper and diluted hydrochloric acid. Yes. Pour hydrochloric acid above the copper metal. Nothing. No reaction. No reaction between copper and hydrochloric acid. No reaction between copper and hydrochloric acid. Why? Because copper is less active than hydrogen. As it follows hydrogen in the chemical activity series. As it follows hydrogen in the chemical activity while zinc and aluminium react. Zinc and aluminium. Why? Because zinc and aluminium more active than hydrogen. And it comes before or above hydrogen in the chemical activity series. Said that zinc react immediately while aluminium take more time. Why? Because zinc react immediately while aluminium takes short time. Why? Meaning due to formation of what? Formation? What else? Because due to formation a layer of aluminium oxide above aluminium sheet, which take more time to remove this layer. Thank you, Anna. Okay. Who's else? Ahmed Ali. Come.
طب وعلي محمد مش هيك؟
Ahmed Ali. Now before the second reaction of assembly substitution, when metal substitute another metal. When metal substitute another metal. When metal substitute another metal. This reaction, in this reaction, we will see how magnesium substitute copper from copper solution. How magnesium substitute copper from copper sulfate solution. Copper, magnesium, what is magnesium? Magnesium strap, yes. We will take a piece of magnesium strap. The form of magnesium metal. This is magnesium metal. This is magnesium metal. We put magnesium metal. Magnesium. Okay. We put magnesium metal in the clean test tube. And then pour some salt solution of copper sulfate. Copper sulfate. Copper sulfate. Copper sulfate. What's the color of copper sulfate? Blue. Yes. Copper sulfate has blue color. Okay. We have magnesium metal and a solution of copper sulfate. Water. How can drink water? Yes. Now we have a blue copper sulfate. The blue color of copper sulfate. When we add magnesium metal to copper magnesium sulfate, yes. Put some copper magnesium above the magnesium metal. Above magnesium. Look at the reaction. No. Thank you. What's happened? No, the blue color disappeared. The blue color disappeared. Disappeared by time. The blue color will disappear part by part. And the silver metal, sorry, the magnesium metal change it to red copper, red precipitation of copper. So take a time. Okay. Magnesium substitute copper port by port. Magnesium substitute copper port by port. At the end of this reaction, what the color of the precipitation? What the color of the precipitation? At the end, no. What the color? Magnesium substitute copper, right? So copper precipitate is formed. What the color of copper precipitate? Red. The color of copper precipitate is red. So at the end of this reaction, magnesium substitute all copper from copper sulfate. Magnesium substitute all copper from copper sulfate for a colorless solution of magnesium sulfate. A colorless solution of magnesium sulfate. And red color of copper is precipitate. And red color, Yamar, of copper is precipitate. We'll leave it to complete the reaction. Okay? After a short time, we will see the red color. Now, let's enter the second type of substitution reaction, the double substitution reaction. Double substitution reaction. Double substitution reaction. The double substitution reaction. The first reaction. Ali, come.
بيسألك علي والله كتير.
علي.
بيسألك علي.
Ahmed. Now we perform the first double substitution reaction between sodium hydroxide and hydrochloric acid. Sodium hydroxide and hydrochloric acid. Sodium hydroxide. Sodium hydroxide. Sodium hydroxide with sodium hydroxide. This is solid sodium hydroxide in solid state. We put some water to prepare sodium hydroxide solution. Sodium hydroxide solution. Sodium hydroxide solution react with this. Sodium hydroxide, the first reaction, the first double substitution. When sodium hydroxide react with hydrochloric acid, double substitution occurs. Double substitution between sodium hydroxide and hydrochloric acid to form what? Sodium chloride and water. Sodium chloride and water. This reaction known as have a name. The reaction between acid and alkali. The reaction between acid and alkali, known as what? Forming a neutralized water. So, known as neutralization reaction. Neutralization. So, what do I mean by neutralization reaction? Reaction between acid and alkali to form salt, NaCl, and water. So, when alkali react with acid, forming salt and water, this reaction known as neutralization reaction. Now we perform the neutralization reaction, the reaction between sodium hydroxide alkali with hydrochloric acid. Let's form this reaction. What's forming? The result is Thank you. This is the reaction between sodium hydroxide and hydrochloric acid. This effervescence due to the reaction. What's forming? Now we have in the test tube. We have what? In the test tube, we have sodium chloride, salt, and water. If we need to obtain the sodium chloride without water, how we can do that? In this test tube, we have sodium chloride soluble in water. If we need sodium chloride only, how we can obtain sodium chloride from this solution? We have water and solid sodium chloride. Evaporate water, right? Yes. If we evaporate this solution, water evaporate and sodium chloride is exhausted. And sodium chloride is exhausted. Thank you. The second double substitution reaction. The second double substitution reaction is here. Reaction between sodium carbonate and hydrochloric acid. Sodium carbonate and hydrochloric acid. Double substitution also occur. Sodium carbonate is salt, hydrochloric acid acid. When sodium carbonate with salt react with acid, what's formed? Sodium chloride and water and carbon dioxide gas. Carbon dioxide.
Yes.
So that when we have a carbonate group in the reactant, it produces what in the product? Carbon dioxide gas. Copy. Yeah, thank you. Sodium carbonate solution. So we put some water, hydrochloric acid. Some water to obtain sodium chloride salt solution. Sodium chloride is salt solution. Salt solution of sodium chloride react with hydrochloric acid and Okay, come on. Thank you. Okay. Now we have sodium chloride, water and carbon dioxide gas evolved. The last activity reaction between sodium chloride and silver nitrate. Two soluble salt. Sodium chloride. Sodium chloride and some silver nitrate. Silver nitrate. Take this amount of silver nitrate and then form a salt solution of sodium nitrate. Add some water to solid. To prepare solution of sodium nitrate. Sodium nitrate by checking it. All the solid soluble in the water. Okay. Sodium chloride with silver nitrate. Then got it? This is sodium nitrate solution. Check. Okay. Now take sodium. Sodium chloride and silver nitrate. Yes. Thank you. White precipitate is formed. Silver chloride is formed. This is the last activity before. Thank you.